All right, Mr. G Math, right? Coming to you live, room 7202. Lesson 2.1, Calculus Rocks. Oh, whatever. The video doesn't care. Did you know that? The video's still pure, even with it not on the screen.
Yeah, but it's
So, relax. See what I'm talking about? One mistake, right? You guys jump all on me.
Hey, one mistake and we should
All right. I want you to look at example number 1. How do you find a limit? Is you do substitution. If you do a substitution and it is undefined, if it is indeterminate, right? That is an indicator, right? That you have to do some algebra. And even when you do algebra, it still might be that, right? So, if I look at 1, what happens when I plug in 0? What do we call it when it's 0 over 0? Indeterminate. Is there some algebra we can do to simplify this? Yes. What do you notice in the numerator and denominator that divide out? And if the x's divide out, what am I left with? Now, can you substitute in 0? Make sure you keep the limit notation until you do the substitution. So now I'm going to do the substitution. Now I have my answer. Try number 2. Jax, are you with me? Are you looking for a pencil to write with? Yeah. I have, like, there's a blue box there that probably has some pencils. I'm going to wait for you. Aw. It's like almost, how much time is it? It's like been an hour and a half into class. Huh? Okay. Number 2, what's the first thing you try to do? Substitute in 2 for x. What do you notice? It's indeterminate, right? 0 over 0. So what algebra can I do to simplify this? The numerator is okay. How about the denominator? Does order really matter if one's positive, one's negative? Notice what happens to the x minus 2's? They divide out. What am I left with if they divide out on top? Now, can I plug in 2? And then what's the answer when I plug in 2? Okay, try number 3. What happens when I plug in 1? Becomes indeterminate. What must you do? You have to factor the numerator. So, how many here remember how to do a difference of cubes?
X plus 1, x minus 1, x plus 1? Question mark?
So, can I show you a different way to do this?
yeah.
Because you don't know how to factor? What happens if I divide the bottom into the top? What would that look like synthetic? Let's say you actually do remember how to divide. Is that an okay assumption? So what would happen if I divided the bottom into the top? Why did I put down positive 1? That's the 0 of the denominator, right? What you're dividing by synthetically? Be so careful here. What numbers do I put here? So the coefficient for x cubed is 1. Remember, it's the big number in front, right? Not the exponent. What's the coefficient for x squared? How about for x? 0. And then the constant is negative 1. What happens when I divide here? What do you notice?
That there's 3 x's. Or, well, no, sorry. It's x plus.
What do you notice? That there's no remainder, right? You know what that communicates when you divide and there's no remainder? That it goes into it evenly. Divide out. What's left over? Just x squared plus x plus 1, correct? We now can do that limit as x approaches 1. Now what would you do? You plug in 1 for x, and what's the limit? See, we didn't have to factor. If we did factor, there's a formula, right? A pattern to cube. This is what it would look like. Do you notice that when the x minus 1's divided out, what was left? Do you see that? Let's say it didn't go in evenly. You could still write it and have the remainder as a fraction and see what divides out, right? And if something didn't divide out, that means that it's not removable, right? And that it gives you the answer there too. Yes. 4. There's more than one mathematical correct way to do it, right? If you don't know how to factor it, do you have any other tool in your box to get in the answer? Yes. Or do you give up? Maybe. 4. What tool do you have to simplify that? I already know, you know, plug in 1, it's 0 over 0. Do you remember from last week? What algebra tool did I teach you, other than factoring, to simplify this? What do we call that technique? No. It does start with a C. Thank you for that.
Conjugate.
Yay, that's right. So, what is the conjugate of root x subtract 1? Now, the numerator we are going to simplify, but not the denominator. Leave the denominator without distributing, okay? What does the numerator become? The numerator. See, no. So, what a conjugate does, it creates what's called a difference of squares. Why is a difference of squares powerful? Because you only have to go first times first and last times last. What's root x times root x? X. What's negative 1 times 1? Negative 1. So what does it simplify to? X minus 1. That's the power of the conjugate, right? Make it simpler. Do you see what happens to the x minus 1s? And what's left in the numerator? Now you can substitute in. And what are you going to plug in? 1. What is the square root of 1? Plus 1. So altogether, what is that? So, number 5. Can you tell me what the limit of x is as it approaches 2 from the right side? So at 2, is that removable or non-removable? It's not indeterminate, right? We know it's undefined, correct? When x equals 2? So you could say this answer from the right does not exist because it goes to infinity. Or you could say this answer goes to positive infinity. Because at positive 2, what would you see on a graph is an asymptote. What's happening to the right of the asymptote? Infinity or negative infinity? And the answer is infinity. What would happen if it was coming from the left? The other answer it could be would be negative infinity from the left. But from the left and right are different. One goes to positive infinity, and the other is to negative infinity. But this is also a good answer. All right, number 6. Discuss it. What are some words we can use about where it's not continuous? So what number do you obviously see that we have to look at? So when I plug in positive 3, what happens to the denominator? It's not, right? And 3, when I plug in here, is 5. So one thing I want you to notice is that the top piece is simplifiable. What is the numerator factored? What would it have been? The numerator, what does it look like if you factor it?
3 plus 3 minus 4.
Do you see that? And that's when x doesn't equal 3. So what happens to the x minus 3's? They divide out. And then underneath, when x does equal 3, what's the answer? 5. So when I plug 3 into the top, what's the answer? 4, right? So, where is there a hole? So when I plug in 3, the answer is 4. There's a hole there. Where does it exist? There's a point where? At 3, 5. Is this discontinuity removable or non-removable? This. Good. So that means what about the limit? That means the limit exists, right? And what is the y-coordinate there of the hole? So what would be the limit as x approaches 3? The answer would be 4. It doesn't matter, it doesn't exist there, right? What is it approaching? What's the y-coordinate approaches? And then when you're there, there's a point that kind of jumps away from the hole. 7. Look at this function. If it's a continuous function, find the value of a. What does it mean if it's continuous? Doesn't lift up, and that x, every x value, right, in terms of connected. So for these two connecting pieces, what's true? That when I plug in 2 for x to the top, and I plug in 2 for x for the bottom, what must be true? They have to be equal to each other. So can you set up an equation where there's an x, you plug in 2, and you make them equal to each other? What would a equal? That's what would make it continuous. If you plug in 2 and they don't have the same answer, it is not continuous. And notice by themselves, they're just polynomials. They're continuous by themselves. So it's only where the pieces meet. What must a equal? Well, 2 squared is 4. 4 times 3 is 12. 2 take away 3 is -1. How would I get a by itself? So what would a have to equal for it to be continuous? And a would have to equal -13. All right, open up Desmos. I'll do Desmos here. But you won't be able to see this on the video. And this is a little counterintuitive, because if you add a graphing calculator, there's actually a function to find the limit of any function that you could type it in with your graphing calculator. I don't think Desmos has that function. So I think you just have to look at the graph and see what the y-coordinate is. Could be wrong. Do they... When I look at... It's nothing there, right? Miscellaneous. Is there any limit here? You can take the derivative. You can integrate. No limit. What's that? See that fancy thing? Looks like a violin symbol. Yeah. And the d of x is a fancy way to say derivative. But I don't see limit. Do you? I don't see it. So guess what? We're going to have to type it in. So type in the top and the bottom. So x cubed plus subtract 3x squared plus x plus 2. And then, oh, I know, I got to put it on print. Thank you. And then the denominator, x cubed minus 2x squared minus x plus 2. Did I type it in right? Okay, look at the graph. What's happening as x approaches 1? Now, what might happen here as x approaches 1? Oh, I gotta get up. Well, what's the y coordinate? It's approaching. What's happening?
Infinity.
It's not approaching a y coordinate, is it? It's going to infinity, isn't it? So, does the limit exist there? And the answer is, it doesn't exist. Because there's no y coordinate, right, that it's approaching. It's going off to infinity. Try the second one. Is it similar? Is it the exact same equation? Yes, but this time it says x approaches what? 2. So click the home button. See this cute little home? Sends you back. What? And so when you approach 2, now you can't see on Desmos, but at 2, do you know what there actually is? Even though you don't see it? Do you see it? Look how cute that hole is. See that little hole there on the screen? Cute little hole. But what's the y coordinate on the left and on the right that it's getting closer to?
0.
Yeah, it's 1/3. And again, that would be a better question to ask if you had a calculator that could actually do limits, which Desmos apparently doesn't want to do. It would be not incorrect to say 0.3 with the tools that you have, but you can see approximately, right, that there's actually a hole there, and it's 1/3. All right, turn the page when you're ready. All right, this is an important theorem in calculus, and often in a free response question where you have to justify your answers, they love the fact if you know theorems that can justify something that you're doing. This is called the intermediate value theorem. So there are a few different things. First of all, the function has to be continuous on an interval. And k is any y value between f and b. Then there has to be at least one x value where c between a and b, where that point would then exist if it's between there. So if you have a continuous function, right, and it's on an interval, so you have two y coordinates, a bottom and a top, or a top and a bottom, because it's continuous, all y values in between there have to exist. It could be more than once, right? But they have to exist at least at a point. So let's say this y value was positive 1. This y value up here was 10. That means somewhere, let's say k equaled 6, there has to be a point where the y value is somewhere between 1 and 10. Because it's continuous. So if you know the bottom and you know the ceiling, that all y values in between exist if it's continuous. It could exist at more than one point because it could go up and down. But it has to exist at least one spot. So what does that mean in practicality when actually solving questions like this? So first it says f at x equals x squared minus x. That's the function. Then you're given an interval. So two questions you need to ask yourself. One, is x squared minus x continuous on that interval? The answer is yes. A parabola is continuous everywhere. One?
Oh, can you say what the intermediate value theorem for again? It's to determine
if a point can exist on that interval. So if it's continuous and you have a low y value and a high y value, then any y value in between the low and high has to exist somewhere in that interval if it's continuous. Because if you draw a pencil and you have to connect it, somewhere along there, that y coordinate exists. But we need a couple things. First of all, is it continuous? Yes. You know what the next we need to know? What's the low and what's the high? How can I find, and it might be the first point is the high and the second one's low and vice versa. But I need to know the bounds, right? So if you plugged in 0 into the function, what's the answer? If you plugged in 5 into the function, what's the answer?
20.
If this y value is in between 0 and 20, then a point exists. Is that true?
Yes.
So how would I find it? I take the function and make it equal to 12 and solve it. So the function was x squared minus x. That y value, right, that 12 exists. What's the x coordinate that goes with it? Because it exists. And could there be more than one point? Maybe. So how would I solve that? So the y coordinate is 12. So you make it equal to 12. Solve it. Make it equal to 0. And then what would you do? How would you factor that? No diamonds. Brains. Negative 4 and... So if you solved it, what would the x value be? Positive 4 and... Now, I'm going to cross out negative 3. Now, I want you to think why I crossed out negative 3.
It's not within the...
What's the interval? Is negative 3 between 0 and 5? So it says find the c value. So our n answer is going to be c. So what's the c value where the y coordinate is 12? And the answer is 4. Can we try b?
Yeah.
So, can you see the function we're given? What's the interval from 0 to 3? And the question is, first, is it continuous from 0 to 3, that function? So a great question to ask yourself, is this a continuous function everywhere? No. At what x value is it not continuous, the top one? Why is it not continuous at x equals 2? There's an asymptote. Is that in the interval? So the intermediate value theorem does not apply. So why does it fail that theorem? Why does it fail that theorem? Because it's not continuous in the interval. What would happen if the interval was from like 3 to 6 or something? Then it would apply because from 3 to 6, it is continuous, right? It just has to be continuous in that interval. But it's not, because at 2, it's not continuous. Okay, find the value of c in example 9a. Did we do that already? We did that already.
Yeah, this is the assignment.
For number 10.
Yes.
What is it, 10?
Oh, so 9 it just says, does it apply? Yes. Then it says find the c value, which we did, right? We already did the work. Over now. All right.